Hello, my name is Avery from Futurology, and today I have the pleasure of sitting down and chatting with retired NASA astronaut and former University of Kansas professor of physics and astronomy, Dr. Stephen Hawley, who has spent over 32 days in space across 5 US space shuttle missions. Today we're going to discuss Dr. Hawley's experience and what it's like to be in space, NASA's Artemis mission to return to the moon, and the future of space exploration, including SpaceX and future missions to Mars and beyond. Thank you for being here today, Dr. Hawley. I'm super excited to chat with you. To kick things off, let's first start by learning a little bit about your background. Where are you from, and when did you first realize you wanted to become an astronaut?
Okay, I'm a native Kansan. I was born in Ottawa, grew up in Salina. I was a student at KU, of course, and majored in physics and astronomy. And yeah, I guess, in my generation, at least when we were starting grade school, we didn't know there were astronauts.
Yeah.
And my interest in space really developed around an interest in astronomy. I had a science unit, maybe in second grade, and part of it had to do with astronomy. Yeah. And I was fascinated by the field, and I decided at that time that's what I wanted to do. I wanted to grow up and be an astronomer. Later in grade school, I think I was in 5th grade when Al Shepard flew the first American in space mission.
Yeah.
And I suddenly realized, that's pretty exciting too. Now, back in those days anyway, all of the astronauts were military test pilots.
Ooh, yeah.
And I didn't want to be a military test pilot. I still wanted to be an astronomer.
Yeah.
But I thought that, it would make a lot of sense scientifically if we put telescopes in space. And I thought, well, let's say we build a big observatory in space, then maybe we'd need astronomers who'd be willing to go staff the observatories in space. And I thought, okay, well, maybe if things work out, I could do that someday.
That's awesome.
Yeah, and maybe not really the astronaut in the traditional sense, but I thought there might be a path that I could follow that would get me into space.
That's awesome.
And so I continued my goal of becoming an astronomer, graduated KU, went to grad school, and got a PhD. And my last year, of course, now that I'm about to graduate, I need to find a job.
Yeah.
And back in those days, the way that worked was universities or national observatories that had positions for new PhDs would send out letters to the different departments around the country and just saying, hey, we've got this opening and here are the requirements and here's how to apply. So this would have been probably late 1976 when I started looking, and I would go down to the bulletin board where these letters were posted, and
You're
a couple of days. No, this was at UC Santa Cruz.
Oh, interesting. Okay, cool.
And see what jobs were available, and usually there were a few that I could think about applying to. Yeah. And then one day, late in '76, I don't remember when it was, one of the letters I saw said NASA on it. And so I started reading it, and what it said was that NASA was looking to select astronauts for this new thing called the space shuttle. And I, was sort of getting kind of excited about this.
Yeah.
And I read the requirements, and you didn't have to be a pilot anymore. You could be a scientist. And I thought, well, I'm a scientist.
Yeah.
Now you had to be, I think, between 5 foot and 6'4". You had to be able to pass a flight physical.
Yeah.
You had to have 3 years of experience after college, and graduate school counted. So I had qualifications, so I could apply.
Fit the needs, yeah.
And that is literally the first time I ever thought about being an astronaut professionally.
That's awesome.
And so I dropped everything I was doing and sent in an application. I think back then you had to request an applications package. So I wrote in, and they sent me an applications package. I filled it out, mailed it back, and that's how this whole thing started.
That's so cool.
Yeah. So basically, I had the skills just by chance, I guess. I had the skills that NASA was looking for because of my plan to become an astronomer. But really, it was also kind of the right place at the right time.
Yeah.
I was getting my degree just when NASA was beginning to look at bringing on new astronauts for space shuttle. So it took a while for that whole process to play out.
Yeah.
And I was left kind of with the same problem. I still had to find a job.
Yeah.
And I eventually did get hired at an observatory in South America.
Ooh.
So I went down there for a year. And
where exactly in South America?
it was in Chile.
Chile?
Yeah,
Oh.
the city where the observatory offices were located was a town called La Serena. The observatory itself was about 50 miles inland up in the foothills of the Andes.
Ooh,
It was really a neat opportunity. The skies are dark. It was only just about, in the early 70s when people built large telescopes in the southern hemisphere.
Yeah.
So for a young scientist, it was a great research opportunity.
Yeah. I can imagine the night sky there must just be incredible.
It's very dark, yeah, and I think it was my first chance to see the southern sky.
Really?
And I thought the southern hemisphere was a lot prettier than the northern hemisphere.
Interesting. Wow. That's amazing.
So there's more to the story, but in the end, I got to go to Houston and be interviewed, and ultimately got picked to be part of the first shuttle class. 35 of us were picked in 1978.
That's incredible. So after you got selected to be an astronaut, what was the process of going through the training, and what would you say was the most difficult experience of that? Did you have to make any sacrifices?
Yeah, I should maybe mention that I actually wasn't hired to be an astronaut. I was hired to be something called an astronaut candidate.
Interesting.
And where that came from was NASA had actually hired some scientists about 10 years before.
Interesting.
And for a variety of reasons, a lot of them didn't stay, they left. And so what NASA did was create the position called astronaut candidate, which was a 2-year job. And so you're hired into this 2-year job, and then you have to demonstrate in those 2 years that
you can be what
they're looking for to be an astronaut. If you're successful after 2 years, then you're promoted to astronaut. And if you're not, what happens is it's a 2-year job, so the job goes away.
Yeah. Oof.
So nobody has to quit and nobody gets fired. The job just goes away.
It's just, you're done.
And so, what I was looking at was, I guess, in terms of a sacrifice, what I was doing was giving up basically my chance to be a research astronomer for a 2-year position where at the end of 2 years I might be out of work.
Yeah, you had no guarantees that it was going to continue.
And I had to show that I could be competent in a lot of things that I'd never done before, including flying jets.
Well, I've seen a picture of you getting off a jet. Was that incredible, flying a jet, after being an astronomer?
Although, when I was first hired, I didn't know whether I had any aptitude for that, whether I'd be able to be any good at high performance jet flying.
Yeah.
And there are a lot of other things too that, I had no experience in, that I didn't know whether I'd be able to do well enough to be able to stay. But I felt that even though, yes, I was making the sacrifice to give up the career that up to then I had been pursuing. Frankly, what I said at the time was, this is your basic once in a lifetime opportunity. So you got to do it.
Yeah, for sure. Not everyone can be an astronaut, right? So that's super awesome. That's incredible. So I guess at what point did you first know that you were going to be launching into space?
Yeah, that's interesting too, because I did an interview a few years ago. This is well after I retired from NASA. Where the reporter asked me, well, how did it feel when you were picked by NASA and you knew you were going to fly in space? And I said, well, I didn't know I was going to fly in space. I didn't know I was going to survive the 2 years. I might be out of work in 2 years. And so then he said, well, okay, but after 2 years, you were now an astronaut. How did it feel then to know you were going to fly in space? And I said, I didn't know we were going to fly in space.
Really?
This was before STS-1. We hadn't flown anything.
Wow.
And if it didn't work, we were all going to be out of a job. So the first chance I had to think, I might actually get to fly in space was after the first shuttle mission was successful.
Wow.
In 1981.
So what was the time gap in between you first starting the astronaut process and then that first space shuttle launch?
It was just under 3 years.
3 years. So you had 3 years of uncertainty of I don't know if I'm actually even going to be able to go into space.
Yeah, some of the uncertainty was resolved because after the program, as I mentioned, was a 2-year candidacy program. But after 1 year, they called us into a big conference room and they said, okay, you've graduated.
Ooh.
So we were all pleased and surprised that
Yeah.
this 2-year program ended after 1 year and they kept us all.
That's amazing.
And at that point, all of us were assigned. Prior to that, we were training in the basics of just learning how the shuttle's built, learning how NASA does business, learning how to fly the airplanes, all of that. Now, we were assigned to jobs to help try to get STS-1 launched.
Perfect.
And so I think for all of us, we felt like this is great because, we're not flying yet, but we're doing things that are going to help, the program get going.
And prepare for future launches that you guys could go on to and get into space with.
Yeah, if the first one's not successful, then we're all out of a job. So we all were working hard to make sure it was.
Yeah, I can imagine. Just all of the commitment you guys had to just keep your jobs and get that opportunity to go into space. So in 1981, right, is when Space Shuttle 1 launched, correct?
Right.
So when did you first know that you were going to be launching on your first Space Shuttle mission? When was that?
I guess it was, I think in February of 1983.
83.
I got a message to report to my boss's office in the headquarters building.
Yeah.
And back then, we kind of had figured out how this works. That if you get a call from the big boss and there's no message, it just says report at this time, could be good news. Not always, but it could be. And so I reported to his office and I found 4 of my friends there.
Oh my.
And we got called into his office and we're sitting around the table and he told us that we were all going to fly STS-12. That's what it was called back then.
Yeah.
So that was, at least I knew I would get a chance.
Yeah.
And he told us don't tell anybody, until the press release comes out. So, here's news you're sitting on. Hey, I'm assigned to a space mission. I can't tell anybody.
Super exciting. You got to keep it within yourself.
Right.
Yeah. Wow.
Yeah. So and that mission actually ended up flying in August of '84. So.
Okay. So like a year and a half.
Yeah. Typically a year was normal back then from crew assignment to launch.
Yeah.
From the time to launch at the time of crew assignment.
Yeah.
But often things would happen and there'd be problems and delays, and it was very unusual to launch, exactly a year from when you were assigned. It was very typical. It would be much longer. Yeah.
Interesting. So after you were selected for STS-12, did your responsibilities and training change completely to prepare for that mission?
At some point it did. Yeah. Initially, nothing changes other than you're now assigned to a mission.
Yeah.
You're still doing the job that you were doing the day before you were assigned to a mission.
Yeah, for sure.
But as you get closer and how close you needed to get depended on how many crews were in training for their flights, how complex the mission was.
Yeah.
But sometime between maybe 6 and 9 months before the launch date, then you'd start to transition out of your sort of normal day job and more into training specifically for that mission.
Interesting.
And that was really fun. We always looked forward to the time when you could start focusing exclusively on your flight.
Yeah. What was your favorite part of that specific mission training? Was there some specific training procedure or something you did that?
Well, we all got assigned specific responsibilities on the flight.
Yeah.
That flight, well, actually we went through about, seems like 4 or 5 different payloads before we actually had one we flew.
Yeah.
Initially we were supposed to launch a tracking and data relay satellite.
Mm-hmm.
That didn't happen because the first launch of the tracking and data relay satellite on STS-6 failed.
Ooh.
And so all of the similar launches were delayed.
Yeah.
So we got different payloads, but we were launching satellites. It was very common before the Challenger accident that a lot of the shuttle missions were devoted to launching satellites.
Interesting. Yeah.
So we had 3. We ended up with 3 satellites, and I was one of the 2 crew members assigned to the satellites.
Yeah.
I was also assigned what we call the flight engineer position. One astronaut works with the pilot and the commander during ascent and entry, sort of like a jump seat in a commercial airliner. Where
interesting.
They don't do that much anymore. Most, I think, commercial airlines just have 2 pilots, but But in the old days, they had 3, and there was a guy in the jump seat, and that was my job. I was the flight engineer. So I got to do a lot of simulations, ascent and entries, which I really enjoyed. I thought it was really fun and challenging to learn, how the systems work and how to respond to failures. And of course, the sims, you get 10 or 12 failures in one sim, and the idea was if you can learn to do that in the simulator, then maybe if you have one real one on launch day, you can handle it. You don't feel overwhelmed.
Over prepare, right? So if something pops up, you're like, I've got it, and you can tackle it immediately. That's awesome. So after STS-12, clearly, the mission was successful. How did it feel? Well, I guess, how did it feel first being in space for the first time, right? What was the physical and mental sensation that you had first being in zero gravity? Or not zero gravity, but free fall.
Right. Well, you're actually strapped into your seat pretty well, and so you don't feel weightlessness immediately. I mean, I'm sure everybody on their first mission grabs the pencil out of their
and then
flight suit and lets it go just to prove you're weightless. The thing I remember though is that when we got to main engine cutoff, you're not actually in orbit yet. You need to make a couple of maneuvers to establish your operational orbit. And so we had to maneuver the vehicle to the proper attitude for the first maneuver. And as we did that, the Earth appeared in the forward windows. Wow. And I remember thinking, holy
That
was a memory that I'll never forget. First time I saw the Earth kind of rise up in front of the shuttle.
That must be just such a...
The other thing, which isn't too romantic, is I thought after my first ascent, the simulator's pretty good. It felt very, obviously you can't simulate the sensations or the noise or the vibration or the G-forces. But the way the systems worked and the displays that you saw and all of that was very familiar. So
really,
I thought, wow, our training's pretty good.
Really? So it was a whole new experience, but in a way, the simulator kind of...
And that's what you want.
I
I had a friend, Joe Allen, who was an astronaut, and he used to say the brain's an amazing thing. It starts working even before you're born, and it never quits until the moment of liftoff. What you want to do is train so that, ascent's really weird, particularly the first time you do it. And you want to train yourself so if something does happen, while your brain's trying to catch up, your first reaction is going to be correct.
So, Dr. Hawley, we've discussed now what this first sensation of being in space was like. But going back a little bit, what was it like first lifting off, on the space shuttle?
Well, I'll describe that, but let me tell you what it was like to not lift off. On a previous attempt. We were originally supposed to launch in June. And actually our first attempt, there were 2 planned holds in the countdown once the crew gets on board. One's at T-minus 20 minutes, the other's at T-minus 9. And when we picked up the count at T-minus 20 minutes, the first thing that happens is the commander reaches up to his computer panel and takes the backup computer to run.
Interesting.
And on that day, it did not go to run.
Ooh, wow.
And so I kind of knew we were out of business. We counted down anyway, and they troubleshot it, but in the end, they scrubbed the launch. And so we waited 24 hours, and the guys down at Kennedy did a heroic job of changing out the computer. And so we're counting down again the next day, and we get to that same milestone, and the commander reaches up and takes the switch to run. It goes to run, life is good. Count down to T-minus 9 minutes. And in those days, that was a 10-minute hold. And now after T-minus 9, when you pick up the count, you don't plan to hold anymore. But there are places you can hold that are built into the final 9 minutes. The last one is at T-minus 31 seconds. And so we start counting down, and we pass T-minus 31 seconds. Now you can't hold after that. You're either going to launch or you're going to recycle. And so as we passed T-minus 31 seconds, the commander said to us, well, gang, I guess we're going to go now unless something really bad happens.
Wow.
And at 7 seconds, the engines start, and I feel the vibration, and I hear the noise. And then at 4 seconds, the engine noise quits. And the noise we hear is a master alarm in the cockpit.
Oh my gosh.
What had
wow.
happened was the engine started and shut down. And so we're sitting there on the pad wondering,
Yeah.
this isn't the way it's supposed to go. Because the engine started, we had some emergency action steps to take that were in our checklist.
Yeah.
And as it just turned out, by chance, in training for 4 to 6 weeks before the launch attempt,
Yeah.
the simulator was having problems with the main engine model, and we were doing this about once every session where we'd have a scrub on the pad.
Interesting.
And
Okay.
we would always play it like a real failure, and so we were really expert at these emergency procedures.
So you were prepared.
We did those,
Yeah.
and then sat back to listen to the control center, and I remember we were still kind of swaying back and forth from the impulse of engine start, and the ground actually the ground called us up and they said, "Hey, we think engine 3 is still running. Can you push the shutdown push button?" Well, we were pretty sure it wasn't running.
Yeah. Oh my.
But we did it anyway. And after some period of time, I don't know how long, from my seat, I could look out the overhead window, but the overhead window is sort of looking at the ground because we're on the side of the tank hanging there, and I could see the pad. And MECO is the acronym we use for main engine cutoff. It normally happens 8.5 minutes after liftoff.
Launch, yeah.
And I said to my crew that, gee, I thought we'd be a lot higher at MECO than this.
Oh, really? That's funny.
And eventually the commander did a press conference and he told everybody I said that.
That's awesome.
And so that line had stuck with me forever.
That's funny.
What happened that day was, I guess you could, put it in the category of a successful failure.
Yeah.
The computer software is designed to check the valve positions in the main engines to assure everything is proper before it sends the commands to light the solids, because once you light the solids,
there's no going back.
There's no going back.
Yeah.
And on that occasion, one of the valves didn't get to the position it was supposed to be in the time allotted, and so the computer just shut it down.
Yeah.
And so there we were. It was, things were pretty calm for a while until people started talking about fire.
Yeah.
And what was happening was hydrogen was still present back at the engines from the shutdown,
released.
And some of it had caught fire. But hydrogen burns with no visible flame, so nobody knew until parts of the orbiter started burning.
Really? Wow.
And so there's a little concern about that. And but eventually, they have a fire suppression system at the pad. They used that, and eventually we were able to get out of the vehicle, and we got totally soaked trying to run across the.
So the fire abort system or fire
suppression system. Yeah, it pours water all over the place.
Oh
so
my
we got
gosh.
soaked trying to get back to the Astro van.
That's so funny.
But in August it took about almost 2 months, I guess, before we could try again. And on that occasion, that was let me think. I think it was August 30th.
Yeah.
The engine start was normal, and the solid rockets fired, and you're going somewhere in a hurry.
Yeah.
It's really loud, and it really vibrates the vehicle.
Do you know how loud in decibels it gets?
Somebody does. I don't know.
Somebody. Interesting.
Well, of course, we're wearing helmets, and so that
helps
protects us some.
Yeah.
It got quite a pretty quickly because a lot of the sound initially is reflected from the pad surface. So as soon as you get high enough, you don't get all of that reflected sound.
Interesting.
But the vibration makes it a little difficult to read the instruments.
Really?
That's not something that we can really simulate very well in the ground-based simulators.
Yeah.
And that lasts for about 2 minutes.
Yeah.
And the G-forces build up to about 3 Gs right before the SRBs are separated.
Yeah.
And then the G-forces fall off again. And I remember, intellectually I know that, but when it happened the first time, it felt like everything stopped.
Was it just all of a sudden being pressed down and then release. Wow. That's
and so I was quickly checking the displays, and the engines were still running. And but after that, I mean, the liquid engines are really very smooth. There's not much noise.
Great.
It was a nice smooth. It's very purposeful, and the acceleration builds up again slowly. When the shuttle was designed, they had to give the engineers something to design to. And in particular, specifically, how you want to mount and hold payloads in the payload bay. And so what they decided was, well, in order to make it possible to design something, we'll just limit the ascent Gs to 3.
Interesting.
And that way, you can build the
something
attachments that'll hold,
withstand 3
times, the weight of whatever your payload is.
That's interesting.
And so we limited that, and that made it a little easier on us as a crew.
Yeah, exactly.
But you build up to 3 Gs, and for the last minute or so, you're at 3 Gs. And
how did that feel physically? Like, was it just like, because I know if you're experiencing too many Gs, right, you can at a certain point kind of lose consciousness.
3 Gs isn't too bad, and that's something we could easily do in the jet, so we would train for that.
Oh, yeah, interesting.
After the Challenger accident, though, when we were wearing a different set of clothes for ascent, we were wearing a pressure suit, a harness and a parachute, and the seats aren't very comfortable and they're not very big, and so what would happen is all the equipment would start to go that way at 3 Gs, and so it would put a lot of pressure on your chest.
Oh, wow.
And it would make it a little tougher to breathe.
Ooh, that's...
I don't remember that being a huge deal before Challenger, because we were really just wearing flight suits.
Yeah, interesting.
Yeah, so that lasts, again, the whole ascent's about 8.5 minutes.
Yeah.
And then the engines quit, and you sort of feel...
just lifted.
Lifted a little bit, but you're strapped into your seat, so you don't feel it a lot, but you start to see stuff in the cabin floating around.
Wow, really?
In our case, we were flying Discovery for the first time, and so we saw washers and iron filings and just stuff left over from construction.
That's crazy.
Floating around in the atmosphere.
Just stuff that people had forgot that just starts floating around.
Just leftover stuff from when they put it together.
That's incredible. So after you launch, right, and you're strapped into your seat, at what point do you first kind of take off your straps and stuff and are able to, kind of get out and fully experience that?
Well, by the time I flew my first flight, we had enough experience from previous flights to know that your first exposure to weightlessness can be stressful.
Yeah. Oh, yeah.
And astronauts were often victims of what we used to call space adaptation syndrome. Basically, you get space sick.
Really?
It's
space sick.
The people felt like one way to mitigate. I mean, the people thought that the cause of basically you get an upset stomach.
Really?
Yeah.
Oh, is it that nausea. Because of stuff in your stomach, maybe?
No, people thought, and I think they probably confirmed it by now, but back then they thought that it was really due to a conflict between what you were seeing and what your inner ear was telling you about your orientation.
Interesting.
So you're looking out and the Earth is upside down.
Yeah.
But you're right side up in the cabin.
Yeah.
And so there's this conflict between what your eyes are telling you and what your sense of up and down is telling you, and that conflict results in some sort of nausea. It's like maybe a little bit like being car sick.
Yeah, nausea. Well, I know, you kind of, when you're car sick, you got to look out the window and focus your eye on something.
Right.
And so it's probably a similar experience.
And so what I was going to do, I just made the decision. I am not going to, some people like to go head first down to the mid deck from the flight deck, and tumble around and weightlessness, and I wasn't going to do that. I actually knew from flying the zero-G airplane, Vomit Comet is what we call it.
Oh, really?
That what you want to do is you want to sit through about the first 5 or 6 parabolas. Just sit in your seat with your seatbelt on.
Yeah.
Then after that, you can get up and start floating around, and you'll do a lot better than the guys, their first exposure to weightlessness. They unstrap their belt, they get up, they tumble, and they, and about 15 minutes later, they're strapped back in their seat.
Yeah, because they're just feeling terrible.
Bag,
oh my gosh.
And feeling really awful. So I wasn't going to do any of that. I was going to stay strapped in till I had to get up, and I had to get up to go back and open the payload bay doors.
Yeah.
But that's probably an hour or so after launch.
Interesting.
So I stayed strapped in for that whole hour and and when I got up, I stayed upright and moved slowly, and
that's super
tried
wise.
to be really careful about
being cautious and making sure, not being too rash and being like,
right.
Oh my gosh, I'm in space.
I figure I got a week to enjoy zero G.
Yeah, exactly. You can ease into it.
I'll ease into it, right.
That's awesome. That's so fascinating. It's interesting to hear about the astronaut experience, right, in space, because I think so many people, they just see the rocket and they don't really know what it's like to be an astronaut inside there, and the kind of procedure you guys go through. So that's super interesting. So yeah, on that first mission, you were up in space for a week.
Yeah.
What all did you do, and kind of what was the mental experience of being up in space, right? You know, you definitely had your fellow astronauts, but was it weird being away so far from the rest of society?
No, I don't think I really thought about it. I mean,
interesting.
Except for the view and being weightless, it was all like being in the simulator.
Yeah.
And frankly, we were busy.
Yeah.
And so we had to launch a satellite within several hours after getting to orbit.
Wow. Close.
So we had to really focus. Maybe that helped, you know, with the space adaptation syndrome, because you had a task to do. So
yeah,
you stayed focused on that.
Mm-hmm.
And we actually had 3 satellites. And we had another experiment, which was a large solar array simulator. It was a simulator in the sense that it actually didn't have a lot of active solar cells on it.
Oh, interesting.
But dynamically, it was built like one of the solar arrays that today's on the space station.
Interesting.
And our job was to deploy it out of the payload bay, and then maneuver the orbiter and measure the response of the solar array. We were trying to determine whether the actual dynamics were close to what we modeled the dynamics to be.
Interesting.
And like I say, that, you know, basically it was, and
it was the same.
Basically
model.
Became what we use on space station today. So
that's super interesting. So in a way, you helped kind of contribute to the International Space Station by.
I like to think so.
Yeah. Well, kind of been involved in a lot of different parts of NASA, so that's awesome. So yeah, you were super busy then throughout that week. What was kind of the experience of, you know, re-entry, and then I know kind of just landing with the space shuttle and stuff? Was that stressful? How was it? Was it interesting?
Well, I didn't find it to be particularly stressful, although to me, the way I've described it before, coming back, I mean, initially, when you start down, you don't feel much different.
Yeah.
Slowly, over time, you encounter more and more atmosphere, and so the deceleration becomes greater.
Yeah.
And at some point, I felt like it's a lot like driving a pickup truck down a gravel road, and you're kind of, being kind of forward in your seatbelt.
Yeah.
You know you're slowing down.
Yeah.
And the G-forces begin to build up.
Uh-huh.
I don't remember if we did it on that flight, but the only mechanical gauge in the whole orbiter is a G-meter.
Interesting.
And so usually what the commander would cover up the G-meter with his hand and say, okay, tell me when you think we're at half a G.
Oh.
And, you know, we'd go, okay, that's about half a G, and you'd look and it's, you know, it's a tenth or something.
Oh, really?
Yeah, you've even in a week, you've lost your sense for, you know, being used to a 1G environment.
That's interesting.
The G's build up to about a G and a half.
Uh-huh. Wow.
One of the things I found that helped was to, you know, I'm strapped in, but you know, march in place.
Oh,
and
interesting.
Keep moving your legs and kind of get some feeling back and get your muscles used to working against gravity. The other thing that we learned early in the program is that crews tended to come back dehydrated.
Interesting.
And the reason for that is when you get into weightlessness initially, it takes your body a while to figure out it doesn't have to work as hard to pump fluids into your upper body.
Yeah.
You know, it has to work against gravity on the ground here, but in weightlessness, it doesn't have to do that. So one of the symptoms you get is you get, kind of a puffy face.
Oh, from water retention in
You
your
feel
face.
like you got a sinus cold.
Interesting.
And over several days, your body figures that out, and you dump water, and you sort of maintain a level of hydration that's normal for being in weightlessness, but it's not normal for being on the ground.
Interesting.
And what we learned was guys were coming back, and they were suffering vertigo and other vestibular issues as a result of being dehydrated.
Interesting.
And so on our flight, we had a protocol to try before entry, which is drinking, I think it was 32 ounces of water and taking 8 salt tablets.
Oh my gosh. Wow.
And
was that?
That's pretty nasty, but
yeah, I can imagine.
And over time, we got a little better about it, and you could drink consomme, and that was easier to take, and it did the same thing.
Yeah, rather than just water and salt.
Yeah, so I didn't want to move my head too much during reentry for fear of starting to spin.
Yeah,
and the commander and pilot also typically would, they had to look around, but they would be careful about it to not, experience vertigo.
Interesting.
So that was interesting.
Cool.
But, after landing, eventually you can get out of your seat. I think, it took 30 or 40 minutes to go through the landing checklist and configure the switches. And then you get up and it's a little hard to walk, and you don't want to fall down the stairs to the mid-deck.
Yeah.
So you're really careful, and you don't want to fall down the stairs to the tarmac as you get off the orbiter.
When you're first standing up, is it just super weird, like experiencing gravity again?
You feel real heavy.
Really?
And you're not used to using your legs.
Oh, so is there kind of like a...
So you have to almost consciously think about, picking up your feet and where you're going to put them down. And
interesting. That's so
things you take for granted, of course, every day here on the ground normally, but you had to kind of think about it. Or you could probably, end up on your nose.
Oh my gosh.
Fortunately, I didn't, but...
That's good. So once you landed, right, and you kind of got back into being on life on Earth, was there ever any moments, right, where maybe initially where you like put something and you expected it to be zero gravity?
I don't think I did that. I know some people that did do that.
Yeah, I've heard
and maybe I didn't because I knew the stories. So,
yeah.
I think we might have played around with, just maybe as we were riding back to the medical facility, we might have said, "Here, catch this."
Oh, and it just
and see
goes on that parabola.
See if you could learn to throw it again, and instead of just floating it over to somebody. Yeah, but no, I've heard of people who would take a glass of water and then just set the glass out, and it would fall to the floor.
Yeah, that's so funny. That's definitely an interesting kind of.
And it takes I don't know. It takes a couple of days before you
fully adapt.
You kind of feel normal again.
Yeah.
I found out later, particularly in the longer duration missions aboard the space station, that you feel normal a lot quicker than you're clinically normal.
Interesting.
So it does actually take longer for your body to really recover than it feels to you. You feel normal long before your
body
really
actually
normal.
really recovers. Interesting. Wow. So that was the whole first space shuttle mission that you went on. So what really kind of did you do once you returned to Earth after that mission? And how far apart was it from the second mission that you went on?
Yeah, so we, when an astronaut's not assigned to a flight, his primary activity is something called a technical assignment. Yeah. And that technical assignment could be you're a capsule communicator, or you're working in Florida and processing the vehicles, or you're doing software verification, or you're reviewing requirements for some new system. Yeah. And that's how you spend your time. Interesting. So once you have flight experience, you're a little more valuable in some of these technical assignments because you actually have seen how it works. Yeah. And so my technical assignment after my first flight was actually to work for my boss as his technical assistant, which was really interesting to see, how he did business and see how, management actually operated. It was actually only about 2 months before I got my next assignment.
Really? Wow. Short duration then.
Yeah, and which was neat. I thought that was really great.
Yeah.
And in fact, before I flew that mission, I got a third assignment. So I actually had 2 flights at the same time, which was not unique, but it was a little unusual.
Yeah.
But the pace of flights was building up, and so it was a little more common for
there to be
somebody to be assigned to 2 flights. And the third flight was the Hubble Telescope Deployment mission.
That's
so I was assigned to that in September of '85, I think. Yeah.
How was it knowing that you were going to help deploy Hubble?
It was great.
And especially after studying astronomy, that must have just been incredible.
Well, I knew kind of the history of the development of the Hubble telescope. The original idea for a large telescope in orbit was due to Dr. Lyman Spitzer, who was a Princeton astronomer who wrote a paper in 1946 talking about all the advantages of having a big telescope in space.
Yeah.
It took some time for the astronomy community to kind of advocate for Dr. Spitzer's vision.
Yeah.
But ultimately, they managed to convince Congress to fund it, and that was about, I think, 1977.
77. So then they started that development.
And they started the development, and of course that took
years.
Yeah. At the time I was assigned, we were going to launch Hubble in August of 1986.
86. So about 10 years of development.
Yeah. Now, of course, what happened was the Challenger accident.
Yeah.
And so everything was delayed.
Yeah.
But it was kind of nice knowing that I had, at least for a while, I had 2 flight assignments. After Challenger, all of the flight assignments were just voided.
Wow.
And so it was sometime later before I got reassigned to that mission. But
wow. Interesting. So after Challenger, right, there was a whole restructuring, right, looking at the missions and reassessing, and like as you were saying before, the equipment that you wore as an astronaut changed after Challenger.
Yeah. The nature of our missions changed too, because President Reagan issued a presidential decree that we should no longer use the space shuttle to launch satellites unless somehow the satellite really benefited from being launched by the shuttle, or maybe if it was a NASA satellite. So we got out of the commercial satellite business.
Yeah, interesting.
And so, I mean, that had been most of what we were doing before Challenger. So
it was kind of refocusing your attention.
Yeah, we had a lot more kind of research missions.
Interesting.
More, telescope deployments. We had, or other satellite deployments for NASA, not for companies.
Yeah.
And that was kind of how it was until later on when we got to start flying to Mir and then building the space station.
That must have been exciting for you, though, kind of redirecting attention away from satellites to like observatories, right? Looking at the cosmos as an astronomy major. That must have been super exciting for you.
No, it really was. And NASA had a program called the Great Observatories, of which Hubble was the first. But the idea was to have 4 major observatories in space that would cover basically the whole electromagnetic spectrum.
Yeah.
Hubble was the first, and Hubble was, at least initially, it was primarily a visual optical light instrument.
Yeah.
It does have some infrared and ultraviolet sensitivity.
Yeah.
The second was Gamma Ray Observatory, which
gamma
the name
rays
suggests, gamma rays, very high energy photons. The third was Chandra, which was the X-ray observatory. And the last one was Spitzer, which was the infrared observatory.
So it kind of covered all those spectrums.
Yeah, and I got to work on 2 of those, Hubble and Chandra.
Yeah.
Ultimately, Spitzer was launched on a expendable rocket, so it was the only one that didn't go on the shuttle.
Interesting. So no NASA astronauts involved with the launch of Spitzer then?
No.
Or was it? Okay, no. So none involved with that. So interesting. So you went on your first mission, right? What year did you launch to help deploy Hubble? What year was that?
We ended up actually launching in April of 1990.
1990. Interesting. So 9 years difference between your first launch and Hubble.
Let's see.
Or was it, you were deployed actually your first launch in 81?
6 years from my first launch to Hubble.
Six.
Yeah, it was 9 years from the STS-1 launch to
Okay,
Hubble.
yeah. 9 years, okay, cool. So what kind of tasks did you have involved with like deploying to Hubble? So
Yeah, the way Hubble was designed to work, it was actually, first of all, it was built to launch on shuttle.
yeah,
So it was built to take full advantage of the payload bay.
interesting.
So it filled the payload bay almost completely. And I mean, it sounds simple, but the idea was we take it to orbit. I would grab it with a robot arm,
Yeah,
lift it out of the payload bay, raise it up, and let it go.
really?
It was actually a lot more complicated than that.
Yeah, wow.
But that was the basic idea.
Yeah,
So we also had a kind of a unique situation because it took up the whole volume of the payload bay. A lot of the stuff that needed to deploy
yeah,
to make the Hubble telescope operational
yeah.
were stowed along the side of the
Oh,
telescope
interesting.
so it would fit.
Yeah,
And so in addition to raising it up and letting it go,
you had to take
we
all
had
the
to take
other
the
stuff.
antennas, get them deployed. We had to deploy a solar array, actually two,
Yeah,
so it would generate power. During launch and early on orbit, Hubble was powered from the Discovery, from the orbiter,
yeah,
with a cable.
interesting.
So when we were ready to lift it up, we unplugged the cable, and now it's on batteries, which is fine,
Yeah.
as long as the solar rays come out.
Yeah,
So we were kind of betting that the solar rays would come out, but just in case they didn't, two of my crewmates, Bruce McCandless and Kathy Sullivan, were trained and prepared to do a spacewalk if necessary
Wow.
to go out and intervene to get the solar rays out.
interesting.
So that we actually had two surprises when we actually went to deploy Hubble.
Yeah,
One was, this is a little complicated, I suppose, but the robot arm has no collision avoidance capability other than the operator.
interesting.
And so,
So if you get it close to something, there's nothing stopping it.
correct.
Interesting.
And the failure you worry about, because we always played the what if game,
Yeah,
is what if a motor fails on
and
and
it hits
starts
something.
to drive the arm and the telescope into the orbiter? What do you do about that? Well, the intervention is the operator sees it and takes action to stop the arm. Well,
Yeah.
that's fine, except if you're an inch from the structure,
Yeah,
you don't have any time to respond.
yeah, if it's moving, yeah.
And so what we did was, through the software, we limited the amount of voltage that could go to the motors.
Interesting.
So if the
was
motor fails on, it's going to move really slowly, and that would give me time to see it and
nice.
stop it before there was a collision.
I'm assuming since it's moving so slowly then, did it take a while to do any movements?
Yeah, but that was okay.
Yeah.
I didn't want to move real
Rush it.
fast when we were close to structure. The problem, though, was when I started to lift it out of the orbiter, it wasn't going the way I was commanding it to go.
Interesting.
And I had no idea why.
Yeah,
And it became kind of stressful because, I don't know what to do
yeah,
to move it in the direction that I need it to go.
yeah,
And so kind of it was trial and error, maybe one joint at a time occasionally, just to, see if we could work it away from. And eventually we got it high enough that I wasn't sweating it anymore. And what I didn't know at the time and wasn't able to confirm till we got back home, the engineers had an idea. And the idea was that because they limited the current so much to avoid this, potential of not having time to react to a failure,
yeah,
that also limited the rate I could command,
yeah.
which was normally fine in the simulator, but the simulator didn't model noise in the circuits.
Interesting.
And it turned out that noise in the circuits was comparable to the size of the command I was issuing. And so I was fighting with the
So the
system
noise actually
itself. Yeah, exactly.
interfered with it. Wow.
And we set up a simulation after I got back where we did model noise,
Yeah.
and we were able to reproduce almost exactly what I had seen. That led to some changes
with the control systems.
With the control system later, yeah.
That's very interesting. Wow. Yeah, you have to adjust for the noise, and if you're operating at such low frequencies or high frequencies, you just got to adapt for that. That's interesting. So, Dr. Hawley, when you were lifting up that Hubble, right, you had some difficulties with, making sure it wasn't going to hit the actual orbiter. What other challenges were there with lifting it up and all that?
The rest of the operations to get it away from the orbiter and in the deploy position worked pretty well. And the reason for that was through the software we could control the rate limiting that had been the problem.
Yeah.
And so once you're far away from structure, you're not too worried about how fast it's going to go if the motor fails on, because you can see it and you got time to react. And once I changed that, it all worked just the way I was used to seeing it.
Great.
So I remember thinking, well, maybe that's our one problem for the day and we'll be good after that.
Yeah.
Well, it's not exactly how it played out. The solar rays were rolled up alongside the telescope, but now that we had room to deploy them, that was what we were going to do. And the deployment was kind of a two-step process. There's kind of a arm that folds away from the tube of the telescope, and then the solar ray deploys like a blind on each side.
Is it folded up, right? Kind
It's
of like
rolled
a
up.
blind. Oh,
Yeah.
rolled up. Oh,
Yeah.
interesting.
And so the way the telescope was positioned, the first solar ray to be deployed was one we could see directly from the cockpit.
Yeah.
And so the ground does the commanding, and they did command it, and we watched it, and it all came out and looked fine.
Went smoothly.
The other one was on the far side of the telescope, but we could see it with a TV camera that we had. And so we were watching it as the ground sent the command, and the canister opened, and the array started to drive, and it drove for maybe a minute, and it stopped. And we reported that. Of course, the ground knew it.
Yeah.
And they tried it again, and it deployed a little bit further, and it stopped again.
Yeah.
And I remember the ground telling us that we had a term that we had talked about pre-flight, which was called power positive, meaning if you don't get both arrays out, do you have enough that you're still going to keep the batteries charged? They're not going to
deplete over
discharge while And they told us that we did not have enough of the solar array out for the telescope to survive. So that meant we needed to get Bruce and Kathy out, in their suits and out the door to do something. And so they were doing that, and I was on the flight deck with our commander, Lawrence Schreiber, and we were trying to help the ground, tell them what we had seen, any troubleshooting that we could do.
Yeah.
Ultimately, what they decided, there was a tensioning monitoring system, because the arrays are fairly fragile, and they were worried that if they deployed asymmetrically, you might get into a bind, and in fact, you might even destroy the solar array. So they had the system that if it monitored, abnormal tension, it would just turn the motors off.
Yeah.
Well, that's what was happening, although the deployment was actually normal as far as we could tell, but the tensioning system kept turning the motor off. So they bypassed that, and
then
the array came out, and that was good. I was feeling a lot better at that point. And then we were able to take the telescope to the actual final release position and let it go.
Wow.
One little footnote, I guess, is that because Bruce and Kathy were in the airlock, we kept them in the airlock because there were a handful of low probability failures that could still happen. For example, if the arm didn't release the telescope automatically, there was a spacewalking procedure where they could go up and disconnect the arm from the telescope to let it fly free.
Yeah.
So as long as they're in the airlock, we're going to keep them there. And so, unfortunately, they didn't get to see the deployment.
Oh, man.
And
it's unfortunate.
I hate to admit this, but the three of us that were on the flight deck for the deployment, as the telescope floated away, we were describing how spectacular it was, what a beautiful, once-in-a-lifetime opportunity to see something like that. I think finally Kathy told us to shut up.
Oh, really? That's funny. Oh, man.
Because they missed it because they were doing their duty as astronauts.
Well, they got to do a spacewalk. Pretty cool. So there's good sides to both.
Yeah. So, so that was how Hubble got deployed. And of course, this isn't really a space shuttle story, but it was maybe 2 months later when it was announced that the mirror of Hubble had a aberration.
Wow.
And, those were sort of dark times for NASA.
Yeah.
Everybody had been looking forward, and, frankly, NASA had kind of hyped the quality of the science, and legitimately so. I mean, and in hindsight, it has been
pretty
incredible.
Amazing. Yeah.
But suddenly now, we can't focus the telescope.
Because there's the aberration. Yeah.
And because the mirror was grounded the wrong shape, and that was really awful. And so I wasn't sure at the time what we could do about it.
Yeah.
In fact, if we could have done nothing about it, the telescope actually would have been quite remarkable. Even with the aberration, we could get the required sensitivity of the telescope, or we could get the required resolution of the telescope. Yeah. The problem was we couldn't do both at the same time. We could pick one or the other. Yeah. So we could have still done great science. It just wasn't
as great.
Some of the science that we had promised.
Yeah.
Plus, we looked pretty bad.
Have an aberration.
Have an aberration in the main mirror of the Hubble. So. Then the question was, what can you do about it? And
how can we fix this? Yeah.
That led to some pretty clever engineering.
Yeah.
That I thought had no chance of working, but it did.
So what was the solution to that?
The solution turned out to be, well, actually, we talked for a while about, could you just build another Hubble? Yeah. And it turns out the reason that came up was because there was a competition between, at the time, Perkin-Elmer and Kodak for the contract to make the mirror. Yeah. And Perkin-Elmer won. And of course, their mirror was faulty. Kodak went ahead and finished their mirror.
Interesting.
And in fact, you can go see it. It's at the Air and Space Museum in Washington.
Wow, awesome.
But we had a mirror. We had another mirror. And so at least the idea came up, could you build another telescope using the Kodak mirror? Yeah. In the end, that would have taken a lot of money, a lot of time, and there was a quicker and easier fix, at least in principle. Yeah. And what some clever guys came up with, based on an important piece of information, that we knew the shape of the mirror. We knew that it wasn't right, but we knew what it was. Mm-hmm. Because an investigation had revealed how it got deformed. Yeah. So we knew what it was, so we knew the prescription to fix it.
Interesting.
And so what some clever guys came up with was the idea of, let's build a box that contains a bunch of lenses and mirrors designed to compensate for the shape of the main mirror as we know it. And then we would take that box and install it in Hubble, and the mirrors and lenses would be on little arms which would extend into the light paths of the other instruments.
Interesting.
And it would correct
the distortion.
The distortion.
That's super creative.
I was concerned that, positioning these things with the precision to make that work seemed like a big ask. But,
super complex.
It was called COSTAR, C-O-S-T-A-R. It stands for Corrective Optic Space Telescope Axial Replacement. Wow. And so it was a box that was built just like one of the science instrument boxes. So on the first servicing missions, the guys had to take an instrument out. Yeah. I think it was a high-speed photometer, and put the COSTAR in its place. And then they extended the arms, and it actually worked. Wow. It was amazing.
That's incredible.
Over time, as we replaced instruments, the new instruments had corrective optics built into them. Wow. And so by 2009, we didn't need COSTAR anymore.
So you could just take it out.
And on the last servicing mission, they brought it home.
Really? Wow. Are you able to see the COSTAR at all?
It's in Air and Space as well.
Wow. That's incredible.
Actually, I got a picture of it on my phone, but
Really? Wow. The power of engineering, that's incredible.
it was really, really clever and really well done. And I was skeptical that the guys would be able to manufacture it with those kind of tolerances and have it work.
Yeah,
but
they did.
Yeah.
It's pretty incredible.
So actually, in the end, Hubble was even better because not only did they correct for the distortion, but the new instruments had more sensitive detectors, and so
able to.
It ended up being really awesome. I don't even know how many people today remember that there was a mirror problem right after we launched it.
I think, most people like my generation, I didn't know that because we see all the successes of Hubble and had no clue that there needed some engineering to solve that initial problem. So that's incredible. That's amazing. So after you deployed Hubble, right, and you released it, I'm assuming you kind of deorbited it again, went through that process. So take us through kind of your process of getting back to Earth, right? And then when did you? So that was your third mission, right?
That was my
third mission. Kind of your process going from there, and then maybe your fourth and fifth missions, and what you did with those.
So when I had actually, before I launched on my third mission, the Hubble mission, I'd gotten a call from headquarters asking me if I'd be willing to consider going from Johnson Space Center out to NASA Ames as a deputy director.
Ooh, interesting.
And I told them maybe I'd be interested, but I didn't want to have to commit till Hubble was behind me.
Yeah.
But I had known when I got picked by NASA that I wanted to make NASA my whole career.
Yeah.
Turns out that isn't exactly how it played out, but and I thought that over time I wanted to be eligible for more responsible management positions.
Yeah.
And I felt like, if I had 3 flights or 4 flights, nobody would probably care.
Yeah.
But if I had 3 flights and some management experience, that might make me
eligible.
Better candidate for, some other positions. So
yeah,
I agreed to go, and I moved from Houston to Northern California.
Interesting.
Did not expect to fly any more space flights.
Interesting.
I was content to get into
management,
and Ames is a research center as opposed to Johnson, which is kind of an operations center.
Yeah. So
and I'm a scientist, so I thought, well, this is maybe I can be helpful. Learn how to manage science at a NASA center. Plus, they did astronomy there.
Cool. Yeah, part of your focus.
So it seemed like a neat fit. I went to grad school in Northern California, so
you were already familiar with the area.
I was familiar with the area.
Interesting.
And I figured I'll do this for a couple of years and see how I like it.
Yeah.
And I did, and I liked it. But I also found that somehow NASA was managing to fly shuttle flights without me.
Oh, really?
And that was a little disturbing. How is it that they can continue to operate the shuttle and I'm not there?
Yeah.
And I realized that I missed it more than I expected to.
Wow.
So I ended up deciding that, maybe managing science is something I'd like to do later. But I kind of need to get back into flight operations. And so I managed to finagle an assignment back at JSC.
Oh, nice.
I was actually deputy director of flight crew operations. It was still a management job. I didn't go back expecting to fly.
Yeah.
I expected to be involved in
the
operations and developing missions and assigning crews and things like that. So that's what I was doing. I think I went back in '92. Is that right? Yeah. And I did that for a few years and enjoyed it. And it was, I liked being back in the flight operations business again and going to launches and being in mission control.
That's awesome.
And one day, I think it was in February of '96, my boss, the director of flight crew operations, called me in to his office and he said, do you want to fly the second Hubble servicing mission?
Wow.
And I was shocked. I mean, I had no...
You weren't expecting it?
I wasn't expecting that at all. I had not lobbied for a chance to come back and fly. I didn't expect to come back and fly.
Yeah.
I probably said yes instantly. But I might have said, well, I need to ask my wife. But so that's how that happened, and so I got assigned to the second Hubble servicing mission. So I was going to get to go back to Hubble.
That's super nice.
Yeah, that was great.
Was it an incredible just feeling knowing like, wow, this incredible telescope that I released, now I get to visit it again? And
yeah, I thought, you know, that's, you know, I mean, Hubble missions were really, you know, everybody wanted a Hubble mission.
Yeah.
And, you know, for me to be lucky enough to get 2 Hubble missions was really awesome.
Yeah.
I remember the first issue that I got to work for the servicing mission. I kind of got bit by something I had said on the deployment mission.
Interesting.
Hubble is covered with this silver reflective surface that's kind of an insulation.
Yeah.
And in the sunlight, it's really bright.
Interesting.
And I remember sort of at the end of the day, we were deploying it, I kind of had a headache, which I thought was from the glare.
Yeah.
And in fact, when we released Hubble and I was moving the arm away, the television camera that sits on top of the end of the arm had no picture. And I thought, well, that's odd. I didn't pay much attention to it because I could see it out the window.
Yeah.
But after a while, and when the telescope was gone, the picture came back. And I realized that the glare was probably more than the iris could handle.
Wow.
And so when I landed and we were debriefing the mission, I said that for the servicing missions, we ought to capture it at night. It's not a huge deal to not have the camera if you're releasing it, but if you want to capture it, if you don't have the camera, that's probably almost impossible.
Yeah, wow.
So I said, if we do it at night, then
it'll be better.
We'll be better. Okay, so now I'm assigned to the second servicing mission.
Yeah.
And I find out pretty quickly that the Hubble team wants to have a color camera on the end of the arm instead of a black and white camera.
Interesting.
Which is what we had always flown. The reason that mattered is because the color camera had a known lack of sensitivity in low light situations.
Oh, interesting.
And I was really concerned if we're capturing this thing at night, I may not be able to see it using a color camera.
Yeah.
And so I was talking to the engineers about that, and I said, you know, we set up an experiment in one of our simulation facilities to try to mimic what the lighting would be like with a real color camera to see.
Yeah.
But I said, you know, the easy way to solve this problem is just capture it in the daytime. Then you don't have to worry about how much light you got. And they go, oh, you can't do that. I said, well, sure you can do that. And I was explaining launch windows and rendezvous phasing and all this other stuff. And I said, you just need to pick the right time to launch. They said, no, it's not that. They said, it's the deploy crew came back and said we can't capture it in the daytime.
Because of the glare.
And I went, oh yeah, I did say that.
That's so funny.
That's so funny. But it turned out that our evaluation suggested the light would probably be okay. And
during the night.
So we did it at night and it worked okay. But
that's cool.
Yeah,
So when you're doing it at night, right, it's night on Earth. So were you able to ever look down and just see kind of like the night sky of Earth, like on the dark side?
Well, what you see typically is light from cities if it's not cloudy.
Is it just lit up with lights from cities?
Well, yeah, I mean, some cities are pretty noticeable.
Yeah.
But I remember one pass at night, the Hubble missions flew the highest that the shuttle could go. In fact, the deploy mission, the second servicing mission were like 1 and 2 in the highest shuttle missions ever flown. And I remember one pass coming over the U.S. west to east, and it was clear across the country.
Wow.
And I could look down and I could see, you know, L.A. and San Francisco, and knowing the geography, I could find Santa Cruz, you know, where I was in grad school.
Yeah.
And then as we, you know, progressed to the east, you know, it's easy to see, you know, Phoenix, Las Vegas, you know, Houston, and I could follow, you know, I-45 up to Dallas, and then I-35 up to Oklahoma City, and then up to Wichita, and then there's a little dot just north of Wichita, which was Salina. I could actually see Salina.
See your hometown.
And then you could follow it. You could see Topeka, and then there's a little dot to the east of Topeka, which was Lawrence.
Where we are today.
And I saw all of these places that, you know, had been important to me growing up, you know, this one night pass over the U.S. That's really spectacular.
That's incredible. That must just be an amazing experience.
Yep, and it's pretty unusual, I think, because frankly, the Earth is cloudy most of the time.
Yeah, blocking it.
I don't remember ever having a pass over the U.S. that was anything like that on any of the other flights.
Wow, that's incredible. That's incredible.
Speechless. So that, you know, you typically, if you don't see city lights, you often see lightning.
Really?
Because a lot of the clouds are storms. I remember on my first flight, it was nighttime. It was probably, you know, after dinner. We were still up before we went to sleep for the night, and I was upstairs looking out the window. And I noticed lights flashing in the payload bay, reflecting off the white liner of the payload bay. And it was interesting because I knew we had an experiment in the payload bay which would shine a light up out of the payload bay, and it was measuring reflected light because it was an experiment to see if we could, you know, measure the contamination, you know, thruster firings, outgassing, you know, things that payload customers might be concerned about.
Yeah, for sure.
But I didn't think the experiment was supposed to be running at that time. So I picked up the checklist and looked, and it wasn't supposed to be running.
Yeah.
And then I realized actually what I was seeing was reflections of lightning from the Earth.
Wow.
And that's when I started to notice how often you see storms.
Yeah.
Now, in all of the missions I flew were 28.5 degree orbits inclination, and that most of the time you're over water. Yeah. And so you do get a lot of storms.
Over the water, wow.
Over the water. At night you can see the lightning easily.
That's super cool. Wow. We had a storm here last night, so if
probably could have seen it from space.
Could have seen it from space. That's super cool. So you returned, kind of got part of the mission operations, and then you were selected for NASA Servicing Mission 2. So what exactly did you do as part of that mission?
Once again, I had the responsibility for the arm.
Yeah.
And so in this case, instead of releasing HST, I was supposed to capture it.
Yeah.
So the way that works is I worked with the commander, Ken Bowersox, and I would be at the RMS controls, and he'd be flying the orbiter, and we'd fly the orbiter up to kind of just come up under HST, and then he would null the rates between HST and the orbiter, and I would grab it with the arm, and then we had a cradle in the payload bay that we could set HST into, and then it had latches, so it would hold HST, and then I could take the arm and let go, and then use the arm to move my EVA buddies around.
Oh, interesting.
For servicing.
You grab them and...
Yeah.
That's so cool.
We had a platform. The arm would grab a little platform that they would stand in.
Oh, interesting.
And so then, you could fly them around and made working on the telescope a whole lot easier.
Yeah.
Because you could just take them where they needed to go. They didn't have to worry about trying to climb around in the spacesuit.
Yeah, in that free fall environment. Just get moved around.
And so we did that. We had 4 scheduled spacewalks. And on the second spacewalk, our EVA team discovered that this silver covering that has
the insulation
was starting to peel on the side of HST that always faces the sun. One side always faces the sun.
Interesting, because it was getting more of those.
Presumably, it was getting
more
the effect of UV maybe from the sun.
Yeah.
And the ground started to get concerned that if the stuff started to flake off, it could be a contamination source.
Wow.
And so they actually gave us a 5th EVA to install some patches that a couple of my crew members were able to make from stuff we had on board.
Really? Yeah. Wow. So how did they make that? What materials did they use?
It's some Mylar. And some clips. It was actually kind of interesting that our pilot, Scott Horowitz, is a really good engineer.
Yeah.
And he was kind of one of the 2 guys working, building the patches. And the ground put together this long procedure on how to build the patch. And they sent it up to him, and he threw it away, and he said, I don't want a procedure. He said, I want a picture. Show me a picture of what you want it to look like.
Yeah.
And they sent him up another, 20 pages of procedures. And eventually, they did send him a picture, and that's what he wanted, and he built it just by looking at this drawing.
That's so funny.
Yeah.
That reminds me, I don't know if you've read it, but the book The Martian, where he, just crafts up all these handy solutions with duct tape. And, NASA is always sending him these super long reports, and he's like, oh, I got it. That's super funny.
Right.
But also
and it worked until on a later servicing mission, they were replaced. I do remember one of the patches we all signed with a black Sharpie.
Yeah.
And,
oh, wow. So your name is on Hubble.
It was until 2009 when it was replaced with a more permanent patch. I remember asking the guy that did that task what happened to our signed patch, and he said he lost it overboard.
Oh.
So,
lost it overboard.
So
it's floating somewhere.
Back. Yeah, if it hadn't re-entered, it's still floating around.
That's so funny. So that was your fourth mission, right? Resurfacing Hubble. So what was your final mission, Dr. Hawley, the fifth one?
Mission was deploying the Chandra X-ray Observatory, which is the third of the NASA Great Observatories. And happy to say it's still working. Hubble's still working.
Yeah.
Compton and Spitzer are not. So 2 of the 4 are still working. But 2 that I deployed
are still working. Hey, coincidence or not?
Yeah, I'll take the coincidence. Yeah, so and that was 1999, and that did turn out to be my last flight.
Awesome, that's cool. So what were your, what did you do after that 5th mission at NASA? And then I know you were a professor here at the University of Kansas. Please take us through that journey of going from NASA to kind of academia.
Yeah, I ended up after my final mission eventually as director of flight crew operations. Yeah. And then my last assignment at NASA was as director of the science organization at Johnson, originally responsible for the curation of the lunar rocks.
Wow, interesting.
So there's astrobiologists and curation specialists, and we also had a couple of other functions that we did, including we modeled the orbital debris.
Interesting.
And we did some testing using gas guns where we would fire particles at different materials. Yeah. And try to marry that with the model of the orbital debris to estimate the probability of finding critical damage on spacecraft. Yeah. From impacts primarily from orbital debris. Yeah, interesting. The shuttle wasn't designed for orbital debris. It was designed for micrometeorites. But and the debris environment has gotten much worse in the years since.
Yeah, no, the situation of satellites hitting each other and then creating this feedback loop of more
exactly.
debris.
In fact, there was a paper, I think it was in 2004, that some of our guys wrote that said if nobody ever launched anything ever again, that the environment would increase for 50 years and then it would increase exponentially. And it was exactly because collisions would begin to dominate
exponentially.
And that was 2004. I mean, so it's gotten even worse. But sometime in there, I got a letter from Chancellor Hemingway. Yeah. And it really surprised me because what he said, I had known him because I was on the Alumni Association Board of Directors for a while. Yeah. But he said, hey, if you ever think of leaving NASA, would you consider coming to KU? And I thought, yeah, I would do that. I got in touch with him and said, yeah, I would be potentially really interested in that, although I wasn't eligible to retire yet. Yeah. And I said, so, it would be a few years before I'd be able to really think about it. And he was okay with that. So we kept in touch for, 3 years, maybe 4 years. I would come to town periodically and visit with him and let him know I was still interested. And when the time came, I said, hey, if your offer's still good,
I'm ready.
I'll retire and relocate. And he said it's still good. So in May 2008, I retired from NASA, and that fall I started here at KU.
That's awesome.
And that was kind of my second dream job, I guess, after being an astronaut.
Professor.
The only thing, a lot of my friends, when they left NASA, they, went into, aerospace companies. Yeah. And that was cool, but I didn't really think I wanted to do that. I thought if I did anything other than being, a NASA guy, I wanted to be an astronomer again.
Yeah, exactly. Go into your roots.
And so, he gave me a chance to do that.
That's
come
so
back
cool.
here and be an astronomer again. So I did that for 10 years and then finally retired for good, although I still do some stuff for the university and like staying, connected.
Yeah, well, you attended my aerospace colloquium, right, and gave the presentation on Artemis, which I think we'll be discussing in just a second. So Dr. Hawley, now that we've discussed your experience, right, your space flights, let's talk about Artemis, right, NASA's mission to return to the moon. Obviously, being part of NASA, you're well aware of Artemis. So the whole premise, right, is, kind of a moon to Mars, right? We went to the moon as part of the Apollo program, and now we're going back with a human presence to kind of test out systems and prepare for a future mission to Mars. What do you think of that approach? Do you approve of the moon to Mars approach, or do you think we should go to Mars directly?
No, I do. And actually, I've got some experience in thinking about it. You probably wouldn't remember, but back in 1989, President Bush, H.W. Bush, gave a speech on the 20th anniversary of the Apollo 11 landing where he advocated, at that time, building Space Station Freedom and then going on to the moon and on to Mars.
Yeah.
And that became known as the Space Exploration Initiative. Mm-hmm. There was some debate then about
the approach,
whether that was the best thing to do. The moon was kind of been there, done that.
Yeah, exactly.
Maybe we should just go to Mars if we're going to go to Mars.
Yeah.
I understood the sentiment, but I thought that we have a lot to learn about living off the Earth. Before we should commit to going to Mars.
Yeah.
We had Apollo astronauts on the moon, but they weren't there for very long. They didn't, their exploration was great. We ran into issues, in particular lunar dust is a big deal.
Yeah.
And so, how do we learn to deal with that? How do we learn to use the materials we would find on the moon or later on to Mars to create
permanent settlements? Yeah.
Settlements. Fuel, breathing oxygen, drinking water, who knows? Exactly. Can we learn how to grow food in an environment like that so we don't have to take everything with us?
Yeah.
I was tasked to be part of a group called the Synthesis Group, which back in 1990-91 was looking at President Bush's vision
constellation
and how we would implement it.
Yeah.
So we gave that some thought. Then, as the shuttle was being retired, President George W. Bush
introduced Constellation,
which was a lot like SEI, Space Exploration Initiative. And again, it was we'll finish International Space Station and then do Moon and Mars, and that begat a lot of the components that make up Artemis.
Yeah,
including
Space Launch
Orion,
System, or Orion.
A version of the space line. Back in the day, it was Ares 5, but it looks a lot like the SLS.
Yeah, and the SLS honestly looks pretty similar to Space Shuttle.
A lot of components, exactly. And so there's a lot of heritage of the Space Shuttle program in the hardware that we're flying. In fact, I think two of the engines on the core stage of Artemis 1 were mine.
Really?
I think I flew them back in the day.
That's crazy.
We're using Space Shuttle components. Unfortunately, we're throwing them away now. On Shuttle, we reused everything except the tank.
Yeah, but just adapting.
But I do think that, it's sensible to develop a program, which I think Artemis is trying to do, where you demonstrate the things that you'll want ultimately to use when you go to Mars. For example, the idea, I think, when we get to Mars is you would have an orbiting outpost of some kind, and you do sorting missions to the surface and back, and that's what the plan would be to do similar to the moon.
Yeah, similar with Artemis and the Gateway, and
we need a new spacesuit for exploring on the surface of another planet or moon. We need habitats. We need to learn how to build habitats. We need to learn how to use we call it ISRU,
local resources, and also scouting for those, right?
So I think it's sensible. Yeah, it takes a little longer. I mean, if your ultimate goal is Mars, this is going to take a little longer, but I think you have a better chance of developing a sustainable
and successful
program
approach
that is successful.
I agree completely. I think a lot of people maybe think, we've been there, done that with the moon. Why do we go back? Just go directly to Mars. But Mars is so far away, and the process to get there, right? The communication alone is way larger gap than with the moon, right? So we can't rely.
And it's interesting to think about, how you would actually do business. I mean, like you point out, you're talking, depending on where the planets are in their orbits, you could be talking 15, 20 minutes one way, light travel time. So the concept of operations, what does the crew do? What's the role of the ground? It's going to be different, because if you got a problem, you're not going to have a real spicy dialogue.
Yeah, it's got to be kind of self-reliant. And therefore,
and those are sort of things you can practice. I mean, the moon is 3 seconds away, so you can practice on how you develop this concept of operations on the lunar surface.
Exactly, and then build that confidence, right? And once we've established that, then go to Mars, where the risks are higher, and you need to have a more solid base to ensure a successful mission. So that's super interesting. As part of the Artemis program, right, NASA has selected SpaceX to provide its Starship HLS solution for the human landing system. There's obviously a lot of controversy, right, with Starship HLS. It was chosen over Blue Origin and Dynetics. A lot of people think Starship HLS is great because it's cheaper and has a promise for quick recycling times, being able to use a lot, frequent launches. However, there is a lot of questioning of whether or not it's actually feasible and whether it will be ready for the NASA Artemis launches. What are your opinions on that, Dr. Hawley? Do you think NASA selecting SpaceX Starship HLS was a wise decision?
Well, it's interesting. The disclaimer is that I'm not really an insider anymore, and I know what I read in the papers and the other reports and the media. But I do have some experience which is relevant. And the thing that kind of surprised me, maybe surprised NASA, is that the original plan was they had a handful of companies, I don't remember how many, was it 4 or 5 that were doing the initial competition. Then they were going to down select.
Yeah, it was Boeing and some other company, and then
and the down select didn't go the way NASA had said.
Yeah.
And the reason was because SpaceX came in with a firm fixed price contract offer.
Yeah.
And that never happens.
Yeah.
Most contracts, in my experience anyway, are cost plus, which means the contractor does the work, they bill the government, they get a award fee, which is the plus if depending on how they perform. SpaceX came in and said, we will do this for this amount of money.
Yeah.
And if it costs more than that, it comes out of SpaceX. If it costs less than that, then SpaceX gets to keep the difference. And my guess, I don't know, my guess would be that kind of took NASA by surprise, because that's not the way we typically do business.
Yeah, not the typical.
And it may have been enough for them to say, hey, that's a good deal. Let's try it. Now the truth is that nobody had any hardware. Everybody had designs, concepts, and so
NASA was willing to.
I'm guessing, but NASA was probably willing to take a chance because this was a good deal. Now NASA got some pushback from Congress because Congress claims to like competition, mostly because they want to make sure their constituents are getting enough of NASA's money.
Yeah.
And so after the first 2 landers, then
the LETS lander, the second stage.
The second wave will be some other companies that are will compete. So we'll see. But again, I don't know, but I'm guessing that the fact that SpaceX was able to make that offer, it was something that NASA couldn't really turn down because it was good for the taxpayers if they can perform.
Yeah, and I know SpaceX's offer was significantly lower than Blue Origin and Dynetics, right? So just from a financial perspective, it saves taxpayer money if SpaceX is able to execute on what they think.
And in SpaceX's defense, frankly, their Dragon program has been successful.
Yeah. So
it took a little longer than we had hoped.
Mm-hmm.
But I was an advocate back in the day, 20 years ago, that we should kind of keep flying the shuttle at a low flight rate to support space station until the commercial guys could prove that they can do it.
Yeah.
And that was not the decision that was made, and it did take like 9 years or thereabouts where we were having to pay the Russians
Yeah, wow.
to launch our guys because we didn't have a commercial supplier.
And now we finally brought that back to launching from American soil.
And they've been successful.
Yeah.
Like, the technology is pretty cool, and they've done a nice job at being able to get our crews up and down from ISS.
That's completely understandable then, right? NASA's had a good history with SpaceX. SpaceX has been able to deliver. So, carrying that forward and kind of trusting SpaceX, especially if they have a better offer, makes complete sense. Hopefully SpaceX is able to, deliver on their goals. Obviously Artemis is super ambitious, trying to send humans around the moon, right, on a free return trajectory next year in 2024, and then landing in 2025, probably 2026, or later, depending on, if that's pushed back. But it's very ambitious, so it'll be exciting. A little bit nerve-wracking, though, to see if SpaceX can hit those targets.
Yeah, and it's the other thing that's going to be a little nerve-wracking, I think, is how the current budget cycle plays out, because the schedule that NASA has is kind of based on the budget that the president released, and if NASA doesn't get that, there's going to be an impact on the schedule. Probably not so much for Artemis 2, because that hardware pretty much already exists.
Yeah, Space Launch System, Orion have been proven.
But beyond Artemis 2, I think you could see a significant slip in the schedule if depending on how that plays out.
Yeah, for sure. It'll be interesting to see how that lines up. Hopefully it's as soon as possible, though. So recently NASA has selected the Artemis 2 crew, right? Are you aware of that? And
yes.
Do you have any opinions on kind of the astronauts?
I know Reed personally, but I don't know the others personally. But to me, they seem well qualified.
Awesome.
So I'm excited for them.
Are there any specific astronauts that you'd like to see as part of future Artemis missions?
Not by name, just because I've been away long enough that I don't really know who's there that much. I do think that you'll see a diversity. And I would look for that. On Artemis 2, we've got a
Canadian astronaut.
Canadian, we've got a male pilot of color, we've got a female, and we've got another pilot who's the commander, Reed. But I think you'll continue to see a diverse group of Artemis astronauts.
And that's great. I think kind of representing people from all around the world and reaching our space exploration
And
missions.
we do have agreements as part of Artemis, as you know, with other countries, and we'll see their
ESA and
their astronauts participating.
That's super exciting. I think that is one of the greatest things about Artemis, right? That it's an international endeavor. It's not just NASA. It's NASA and all the partner companies and space agencies kind of working together to achieve this larger mission that's not just for the United States, but for all of humanity. It's pretty incredible. So I guess, that's kind of what we've covered on Artemis. If you're ready, I think we can now open up to maybe like a more general discussion of space, kind of the trends shaping the future. One of the most exciting, of those is James Webb. As someone who's studied astronomy, an astronomy professor, I'm sure you're super excited about James Webb and all of the potential of it for research into astronomy.
Yeah, and it's going to, the one thing I would say as a disclaimer, Webb is awesome, but before it was launched, it was generally portrayed as the successor to Hubble. Well, that's true in the sense that it's the next big space telescope, but I want to take this platform to say that when Hubble is no longer functional, there is no replacement for Hubble. There isn't anything that does what Hubble does. Webb is awesome, but it has a specific mission that isn't exactly the same as Hubble's mission. Although it's really good that there's overlap. That Hubble is still operational at a time when Webb is operational. And that's going to be tremendously valuable to the science. But Webb was designed specifically to look back in time near the beginning of the universe and hopefully study the first stars and galaxies to form. Because frankly, we've got a problem. We don't know how to make stars and galaxies as rapidly as the universe apparently did. and hopefully Webb will help us get to the bottom of that.
Yeah.
And the fact that it's operating so well and all of the stuff that had to deploy
worked.
I was very nervous about that, but it's been a tremendous success story.
Super exciting to have James Webb out and just see all the amazing things it discovers in the coming years. So kind of, we've been talking about SpaceX, right? Recently, in the past decade or so, there's been a huge kind of trend of the privatization of space now. We have like Blue Origin, SpaceX, a bunch of other companies that are kind of transforming space exploration in a way. What are your thoughts about this, especially having worked for NASA, a government agency? What do you think?
Well, I would say at the top level, this is the way it's supposed to work. Mm-hmm. What I mean by that is, historically, the government takes on the challenges that are technically difficult and probably expensive and risky.
Yeah.
Because a company really
can't afford
to do that.
Yeah.
Now, when the government succeeds and develops as a result of that investment something that can be useful, then the companies will come in and they'll figure out how to use it, make some money, build an industry. I think that's
turn it into an economy.
Exactly the way it ought to work.
Awesome.
My only concern is that the extent to which we're focused on tourism could be an issue, because I don't know how sustainable that is as a business model.
Yeah.
I got no problem with
space tourism.
With tourism, but if all these companies are building capability hoping they're going to get tourists and there aren't enough tourists.
Yeah.
I mean, right now, frankly, you have to be rich to
or
know somebody that's rich.
Yeah.
Are they going to be around? Are they going to go out of business? I mean, I don't think SpaceX is going to go out of business, but will we lose a lot of the commercial capability that's being developed? So I would like to think that there'll be people that'll come along, they'll have other ideas. And I know there are companies that are thinking about really weird things like mining asteroids.
Yeah.
So I hope people continue to think about that. That's probably beyond the reach of what can be done right now, but
in the future it might open up.
Future you might do that. I remember back in the 80s, even we at NASA were talking about solar power satellites.
Yeah.
And I know some guys at the University of Houston back then that were looking at solar power on the moon that would then be transmitted to the Earth. So, I mean, are there ways we can use space to provide energy for people on the Earth? Anyway, just a couple of crazy examples, but I would like to see, people giving some thought to how could we use this capability to do something other than tourism.
Yeah, open up into different industries. That's super fascinating. What are your general opinions about SpaceX, right? They're super ambitious, and I think a lot of people are interested in them. Mostly, right, because of Elon Musk's goal to get humans up to Mars, right? Potentially by 2030. Do you think that's feasible? And if so, do you think, SpaceX is going to be able to reach those goals?
Yeah, it's interesting. I guess I'm sort of naturally skeptical. Mm-hmm. And I remember having back in the early days of SpaceX, they were not having a lot of luck recovering their boosters.
Yeah.
And I remember having dinner one evening with a guy that was a SpaceX kind of launch site manager.
Yeah.
And he was talking about, SpaceX's goal was to, recover the booster and launch it again in 4 hours. And
wow.
And I was thinking, well, that might be cool, but do you need to do that? I mean, is there a business model that says somehow that makes sense?
Yeah.
I don't know the answer to that, but I would say that the technology that they have managed to demonstrate is very impressive.
Yeah. Landing rockets is something that nobody used to think of.
And I don't know how many. I was at the SpaceX facility last year at Kennedy, and I saw a lot of the Falcon 9s being refurbished, and I think at that time their high time Falcon 9 booster had like 11 or 12 launches on it. And,
wow. Yeah.
So I mean, that's all impressive. So even though I'm skeptical, I would hate to say, I don't think SpaceX can do it, because
they've already proven some pretty
SpaceX has done stuff that I already thought they couldn't do.
Yeah, for sure.
30 would be pretty optimistic.
Yeah.
But, again, if you got a lot of money and a lot of desire,
yeah,
it sort of moves the bar.
Yeah, for sure, for sure. So now that we've discussed about SpaceX, I think, right, we've kind of generally covered the largest things that are, shaping the future of space exploration. There's still obviously other things, but, we are on a little bit of a time constraint. So, Dr. Hawley, to kind of end our interview, right, do you think, what is the true value of space exploration, right? Because I think a lot of people see, wow, it costs billions of dollars to get these people, to get astronauts to the moon and stuff. We've already got to deal with climate change, pollution, water issues, all these issues here on Earth. What is the true value of space exploration and investing in that? And so I want to hear your...
Well, I think it's multifaceted, and I know maybe some people think we load up nose cones with lots of dollar bills and launch them into space.
Yeah.
But of course, the one thing is that the space industry historically has provided really good jobs for people.
Yeah.
And has been, I think, at least when I was growing up, it was sort of a pull for us who had some interest to, study science and math in school, because there's a chance that, maybe you'd get to work in the space industry one day.
Yeah.
This is probably out of date, but when I was late in my NASA career, the statistic that we were sharing was that every dollar spent on the space program returns 8 to the economy.
Yeah.
And some of it's, some of it's technology, some of it's just good jobs. There's also sort of an intangible component that I ran into personally when I was a postdoctoral fellow before I was assigned, before I was selected by NASA, and I lived in Chile.
Yeah.
And one day I was walking down the street, and some guy comes up to me, and he asked me if I was an American.
Yeah.
And I said, yeah. and he said that television had come to Santiago in 1969. And one of the first things he ever watched was the Apollo 11 moon landing. Yeah. And he told me that is the most amazing thing he had ever seen in his life.
Yeah.
And that struck me because, it was for me too, but I'm an American.
Yeah.
And for Americans, that was, a tremendously moving, awesome
source of
thing
pride
to watch. But here's a guy living in South America, and it was the same for him.
Yeah.
And what I realized was that the things like that we do impress people all over the world.
Yeah.
It's a way, for the U.S. to maintain some prestige in the eyes of other people.
Yeah.
At least that was the case back in 1977.
Yeah. I think it holds true to today.
I mean, why is China, aggressively pursuing, missions to the moon?
Yeah.
Russia's still probably more got it set on Mars than the moon, but of course they've been a spacefaring nation for a long time.
Yeah.
Other countries are developing some capabilities. Why did they do that?
Yeah, there is a reason.
There is a reason. And I would say, if you took NASA's, if you could tell me I could take all of NASA's budget and give it to somebody that would solve all of the world's problems, I'd probably do it.
Yeah.
But
Can
that's
you do
not
that?
realistic. So
Yeah.
the best you can do is try to help where you can.
Yeah.
And with developing new science, developing good jobs, trying to attract young men and women into
STEM fields.
When in the shuttle program, there were countries around the world that wanted to fly,
Yeah.
one of their citizens with us.
Yeah.
And, that was, turns out in some cases that actually turned out to be national policy implications.
Yeah.
That, we developed a relationship with, this other country because one of their citizens was offered a chance to fly on the space shuttle. I wasn't a huge fan of that, frankly, as a crew member, but it was true.
Yeah. That's super fascinating, Dr. Hawley. I think, just Artemis and also space exploration in general is something that maybe doesn't have a concrete, fixed price benefit, but just in large, something incredible for humanity that everyone can celebrate and enjoy. So to recap, or to kind of finalize our conversation, I'd like to ask you if you have any advice, maybe, right, for people who are watching, based on your experience, your wisdom, if there's something you can share to viewers, especially young viewers, to inspire them, to maybe pursue STEM or chase your dreams and what is possible.
Well, let me think. I would say a couple things. I never realistically thought I would be an astronaut.
Yeah.
That just wasn't, being an astronomer was possible, being an astronaut was not.
Yeah.
What made it possible was the opportunity came up and my training enabled me to take advantage of it. So I would say maybe the takeaway is you never know what opportunities may be presented to you.
Yeah.
And the best thing you can do is be as prepared as you can be to take advantage of those opportunities when they happen. Exactly. And so maybe that's one point. Another point might be, I kind of learned this in college, here in honors calculus. They carried over to NASA. It turns out, at NASA, when the people that train us for flight have never flown in space.
Yeah.
They know the systems and they know why you do the procedures the way you do, but they've never done it. And so my point is that I learned that you really need to be your own worst critic.
Yeah.
You need to be honest with yourself about what you're good at and honest with yourself about what you're not good at. I mean, I've heard people use the golf analogy where you go to the range, everybody wants to hit drivers. Well, maybe your wedge game's no good. You got to work on your wedge game or your putting. But, be honest and try to identify the things you'd like to be better at and commit to working on them.
Yeah.
High school was easy for me.
Yeah.
When I came to KU and started taking honors courses, I found out everybody else in the class, high school was easy for them too.
Yeah.
And I needed to work harder and to be more disciplined at, okay, did I really understand what the professor was saying today? And if I didn't, I needed to figure out what I needed to do in order to understand what he was talking about. Yeah. So I think developing that discipline, whatever you're doing, to be able to honestly say, okay, I'm really good at this, I'm not too good at this, and I need to work on getting better at this.
Yeah.
And the last thing I learned, one of the things I really loved about NASA and miss about NASA is the quality of the people and the teamwork.
Yeah.
There's some just amazing teams that I was part of, including flight crews, including mission control teams. So one of the things I learned about being a good team member is, first of all, be very good at what you are responsible for. Mm-hmm. But then do what you can to help your other teammates be really good at what they're responsible for. And if you can do that, then you will have a very successful team.
Yeah.
And
collaborative environment.
Collaborative environment. I used to tell it this way, particularly during my second mission, when it kind of occurred to me to think of it in these terms, is that when our crew was in the simulator, and if I screwed something up, the control team and the instructors wouldn't say, Hawley really messed that up today. What they would say is, the crew really messed that up today.
Yeah.
And so everything I did reflected on them. And so again, I wanted to be as good as I could be at what I was supposed to do, but I needed to help my teammates be really good at what they were doing too.
Yeah, because everyone's treated as a team, right?
That's right.
You work together to accomplish the task at hand. So that's super interesting. So Dr. Hawley, I know you've been working on a book recently.
Been trying to.
So if you wouldn't mind kind of sharing with the audience what that's about and how they can maybe eventually look into it and maybe buy it.
It's been a kind of a long time in work, because originally I thought I was never going to write a book. A lot of astronauts have written books, and I didn't see a reason to write one. Yeah. But I found when I was, over the years giving talks, people would come up after the talk and say, "Oh, that was really interesting. You got to write a book."
Yeah.
And to be honest with you, I still wouldn't have done it, except my younger brother developed cancer several years ago. And so I spent a lot of time Zooming with him, just try to cheer him up, talk to him about his stuff. And I found out that I didn't realize how much he had been interested in my career.
Yeah.
And he would even say things like, "Oh, well, do you remember the time you told me X?" And I would say, "Well, I forgot about X." And so what I did, I started writing down a lot of the things that I did and a lot of the stories. And my plan was to give it to him. Unfortunately, he died, and I wasn't able to do that. But I decided to go ahead and carry on.
Follow
through. And as I did that, I was hearing a lot of talk about the Artemis generation.
Yeah.
And comparing it to the Apollo generation, but nobody's talking about the shuttle generation.
Yeah.
And I thought, well, it's important to me at least that we preserve, the history of what the shuttle did.
Yeah.
And so that became sort of a secondary goal of not just talking about, my experiences, but also what did we do as the shuttle program, at least from my perspective as I saw it. I was there before the first flight and didn't quite make it to the last. I came to KU before the final flight, but
you were there for the vast majority.
I was there for most of it, and I had positions in management that allowed me to
get direct access,
to be behind the scenes, be in these meetings where the decisions were made, and why were the decisions made, and I thought, hopefully that would be important to capture. So I'm working on it, trying to get that, completed, and we'll see what happens.
Very excited to see it. I'll definitely give it a read. So if you're interested in learning more about the space shuttle, please check out for Dr. Hawley's book whenever it comes out. I'm sure it'll be a great read, and you'll be able to see the behind the scenes of how the space shuttle system operated and the operations behind it. So that'll be great. I think really that's all we had planned to cover today. So it's been an honor.
Appreciate it. Thank you.
Dr. Hawley, thank you for chatting with me.
Yeah, thank you for letting me relive some of these experiences.
Yes. All right. Thank you for watching, and we'll see you next time.